Good morning, friends. Myself, Y. M. Harde. Today we have see the flow-through pipes. Presently, I am working in Rajarshi Shahu Maharaj Polytechnic, Nasik. So today we have see the flow-through pipes. In that, fluid mechanics and machinery subject under, we see the what is the HGL and TEL. So let's start. So in previous lecture, we see the minor losses. So firstly, see the diagram. So firstly, HGL. So in liquid there are the three energies: pressure head, datum head and velocity head. So out of that, HGL is, see the definition, it is defined as the line which gives sum of pressure head, datum head of fluid flowing pipe with reference to some reference line. So HGL may rise the or fall depending upon the pressure changes. So formula of that formula for that is P upon W plus Z or P upon rho G plus Z. So that is a hydraulic gradient line. So it is defined as which gives the sum of pressure head, datum head. So next is a total energy line. So the total energy line which gives sum of pressure head, datum head and kinetic head. So next is a total energy line. The line which gives sum of pressure head, datum head and kinetic head of flowing fluid in a pipe with respect to some reference line. When fluid flow in a pipe, the loss of head energy in the direction of flow is looking as a flow. So total energy line is P upon W plus Z plus V square upon 2G. So write down the definitions. शॉक लागला असं नाही करायचा. काढते तुला काढते पटकन ते तुटल ना दुकान बंद आहे. थोडं सांगू तुम्ही आणि कडचं. So let's see the figure. HGL and TL. It consists of two reservoirs in which the water is flowing from A reservoir to B reservoir. Out of that, there are show the two lines. That is a sudden contraction in the pipes. So when your water flow in that pipes, the suddenly expansion is happened. So in that, the line which gives sum of pressure head and datum head with respect to datum head, datum line. So it is called total hydraulic gradient line. Hydraulic gradient line below the total energy lines. ये very important sentence है. Hydraulic gradient line lies below the total energy line. Next, total energy line is the sum of velocity head, pressure head and datum head. The total energy line lies above the above the hydraulic gradient line. So in graph shows there is a losses, there is a expansion, contractions, and it connect to reservoir. So there are the three total energy lines, and these are the total energy line and hydraulic energy gradient line. So draw the figure. So next task is pipe in series. So what do you mean pipe in series? The compound pipe or pipe in series, it is also called as compound pipe. So when the pipe of different length are and diameter connected to each other to form a pipeline, then such a pipeline is called as compound pipe or pipe in series. So the figure shows the pipes are in series. The discharge through each pipe will be same or continuous. So if the piping system is formed by joining pipes of different diameter and length in the continuation as shown in the figure, these are to be said pipe in series. Let the pipeline connecting two reservoir by compound pipes and the difference in the liquid surface level is equal to the sum of head losses in all sections. So let's see the three pipes L1, L2, L3. 1, 2, 3. Let L1, L2, L3 be the length of pipe 1, 2, 3. Similarly, D1, D2, D3 be the diameter of 1, 2, 3. So H is a total head loss. Q is a total discharge. So similarly, D1 is a diameter of pipe 1, L1 is the length of pipe 1, F1 is a friction factor of pipe 1. Similarly, D2, L2, F2, D3, L3, F3. So by considering all the by considering all losses, so total losses is equal to major losses plus minor losses. So due to major losses, H is equal to HF1 plus HF2. So major losses due to HF1 is 4FLV square upon twice GD, 4FL2 V2 square upon twice GD plus 4F3 V3 square upon twice GD. So minor losses as entrance loss, contraction loss, expansion loss and exit loss. So HL is equal to 0.5 square upon 2G plus 0.5 is 2 square upon 2G, V2 minus V3 square upon 2G, and add exit losses. So by combining these two equations, H is equal to 1 upon 2G FLV square upon 21, FL2 V2 square upon D2, F3 L3 V square upon D3. So if discharge through pipe is given by H is equal to F1 L1 Q square upon 12.1 D1 raised to 5, F2 L2 Q square upon 12.1 D2 raised to 5, and F1 L3 Q square in upon 12.1 D3 raised to 5. So these are the pipe in series. So let's draw. झाले का ड्रॉ करून? So next is a pipe in parallel. Next is a pipe in parallel. So the figure shows pipe in parallel. So due to that, the figure 2 shows pipe in parallel. So pipe in parallel is said to be connected the pipe in parallel when they divide into two or more parallel pipes which join again downstream. The figure shows upstream and downstream. The discharge in the main pipe is equal to the sum of discharge in the each parallel pipes. Let's see the figure. The point A is a upstream, point B is a downstream. So discharge is same. Whenever liquid flowing through pipes, two pipes which is are in parallel. So P1, pipe 1 and pipe 2. So if two or more pipe are joined in the form of single pipe, then are said to be parallel. So in that pipes, there are the in that pipes, pipe 1 and 2 are in parallel between A and B. In this case, Q is equal to Q1 plus Q2. So when A in Q1 side pipe 1, Q2 side pipe 2, Q is equal to Q1 plus Q2. So that is HF1 is equal to HF2. So F1 L1 Q1 square upon 12.1 D1 raised to 5 is equal to F2 L2 Q2 square upon 12.1 D raised to 5. So in this way, we calculate the pipe in parallel. So the figure shows same pipe in parallel. So let's write down. So today we have seen the HGL and TL. Again I repeat all. HGL is a hydraulic gradient line. P upon rho g plus z, total energy line. So to P upon, it is a sum of pressure head, datum head and kinetic head. HGL is a sum of pressure head and datum head. So it is may fall on depending on changes. When fluid flowing through pipes, there is a loss of head and type total energy decrease in the direction of flow. So P upon rho g plus z plus V2 square upon 2g. So this is the figure of HGL and TL. There is a losses. Next, pipe in series, different length as shown in figure. Three pipes are in series, L1, L2, L3, diameter D1, D2, D3. So there is a HF is equal to HF1 plus HF2 plus HF3. So pipe in parallel, HF1 is equal to HF2. So Q is equal to Q1 plus Q2. If two or more pipe join in the form of single pipe, then are said to be parallel. So let's see the next in next lecture. Thank you.